Welcome to the HIT model video training provided by Grand Valley State University. These tutorials were developed by the Water Resources Institute to help stakeholders in the West Michigan region become more familiar with the HIT model. My name is John Vandermolen. My contact information is listed right here on the webpage if you have any questions about the tutorials. Other questions specific to the HIT model can be directed to Glenn O'Neill at Michigan State University's Institute for Water Research. His contact information is also available on this webpage. In this tutorial, I would like to show you how to use the HIT table. To do this, we have to go to the HIT Model Project webpage by clicking on the Go to HIT Model link. When arriving on the HIT Model Project homepage, under the Data Access heading, click Straight to Map. This will bring you to a map of the Great Lakes Basin provided by Bing Maps. Zoom into the area northwest of Grand Rapids, Michigan by pushing on the magnifying glass in the upper corner with the positive sign in it. You may have to do this 4 or 5 times to get to the area desired. Also, you may have to pan the map to center the area for which you want more detailed information for. You can do this by pressing on this glove, going to the map, left-clicking the mouse, and dragging it left or right. Continue to zoom in. Activate the Local Subwatersheds layer, HUC12, in the Map Layers box. You can do this by pushing on the circle and the box next to the layer name. In order to get data, you must first select a watershed. For this example, we're going to use the Sand Creek watershed to the northwest of Grand Rapids, Michigan. The Sand Creek watershed is a tributary of the Grand River approximately 22 miles in length and located on the border of Kent and Ottawa County in Michigan. Sand Creek is made up of 3 HUC12 watersheds, the Sand Creek Headwaters, Sand Creek, and the East Fork. The watershed's land use is mostly comprised of agricultural lands. To select the 3 watersheds that make up the Sand Creek watershed, click on Select Watersheds and on Map. This will give you the crosshairs in order to select the watersheds. The sub-watersheds to be selected, again, are the headwaters of Sand Creek, the East Fork, and Sand Creek. You may now zoom into these to get a better view. Again, notice how you are northwest of Grand Rapids, Michigan. Now that watersheds have been selected, you can get HIT data. To get the HIT data table, click on HIT data in the HIT Tools toolbar. A HIT data box will appear asking you 3 questions. The first question is, do you want to view erosion or sediment loading data? Click Sediment. The second question is, are you interested in rates and/or totals? For this example, select both boxes. For right now, click on Make Table. A new window appears in the Internet browser with a table showing the watershed name, the hydrologic unit code, the size of the watershed in acres, the total tons of sediment per year, and the rate of sediment per year in tons per acre per year. You'll notice to the right of the word sediment a sentence saying, click on a column title to sort ascending. Let's practice that. Click on the acres heading. Doing this will refresh the table and sort the watershed size from smallest to largest. Notice that the smallest watershed is the Sand Creek watershed, and the largest watershed is the headwaters Sand Creek. For right now, let's go back to the HIT data table by Xing out of this screen. The third question in the table is to specify any BMPs you would like to evaluate. For this example, click on Mulch Till on worst 5% of a watershed, No Till on worst 5% of a watershed, and Grass on 5% of a watershed. Click Make Table. Once again, a new window appears in the Internet browser with a table showing the watershed names. Maximize this window. Take a moment to review the columns of the HIT data table. The first 3 columns in white display some basic information about the selected sub-watersheds. The gray columns display the estimated sediment loading in both tons and by rate. The black columns show an estimated reduction in sediment loadings for each of the BMPs selected previously. And the green columns show the cost benefit in dollars per ton of sediment loading reduced for each BMP. So where can the stakeholder get the most bang for the buck? The answer is under the BMP cost benefit heading. According to the HIT model, the most effective way to reduce sediment in the Sand Creek watershed is to no-till the worst 5% of the area in the watershed. Specifically, applying this BMP to the headwaters of the Sand Creek is the most effective way for a stakeholder to use their monies. Finally, if the user feels that the cost to implement a particular BMP does not reflect the current market value, they can change the value of a BMP to be more realistic. To do this, the user must enter dollar value under one or more BMPs under the Specify New Value to Recalculate BMP Cost section. For example, change the BMP cost for no-till on worst 5% of area from $14 to $21. Push the Recalculate BMP Cost button after doing that. Maximize the window. Notice that the overall most cost-effective BMP is now mulch till on worst 5% of area. This concludes this section of the tutorial. The user should now know how to view HIT model outputs using the HIT data table, how to determine the most cost-effective BMP to implement in a watershed to reduce erosion and sediment, and how to change the cost of a BMP to better reflect the current market conditions.